So I'll share my screen. Can you confirm that you can see my tablet?
Yes, sir.
Oh, okay. So we had already started to do some physics problems last time, so we will continue with that today also. And we had a couple of problems left from previous topics, so we'll come to that later at the end of today's class because we already covered those topics in other examples. So I would like to focus on other topics first, and then we will come back to that later. But before that, just one small comment I would like to share about how you should prepare about this exam, or in general how you should orient your studies, because I saw this question from few students on the group and even outside that you are interested to know the syllabus of this exam, right? So I want us to start thinking about this word slightly differently. So syllabus. So, typically we use this word syllabus in school or college, maybe where we have a particular course which we have to go through. We have to cover some concepts, and those concepts are typically tested in the exam. But I think what we have to start thinking is not just the syllabus, but more in terms of the broader application. Okay, so it is not just that, these are the topics that you need to know, but you also start to have to think how to apply these topics. Okay, so it is not just the syllabus, it is the application which is equally important or more important for an exam like this. And you have already seen this, right? In all the topics we have seen so far, the topics which are studied in school, it is the same syllabus, but still the question can be of a different nature where the application is the important part. So you should start to think more and more in terms of this application, and the word syllabus should slowly disappear from your vocabulary, because just think about it, right? Eventually you cannot keep thinking in terms of syllabus all the time. You are going to go into college, and then maybe you'll apply for a job interview somewhere. Can you imagine that you ask the job interview what is the syllabus of this interview? That is not possible, right? So you have to start thinking about application as quickly as possible. And I would suggest that that is just the middle stepping stone. You have to go further than application, because application is finally you're applying things to solve known problems. But if you want to really contribute something new, you have to move to what I'll call innovation. So innovation is where you try to discover new problems, that problems which nobody has thought of before. And if you try to do that, you will start to explore the theory in much more detail. You will start to appreciate many small things. Like, for example, what we talked about last time. Every time we solved the equation, we got one positive root, one negative root. So now you should start to think, what is that negative root? What does it mean? Things like that. So you have to start slowly expanding your horizon in this direction. Okay. So this is very important for you to help prepare for this exam, but also this is a general guideline for you to prepare yourself for all the future education and career that you will be facing, because one important force which I think you already have some idea that you see artificial intelligence everywhere. You must have seen chat gpt, and largely speaking, like if you have to put labels to this, like what the syllabus is testing is your knowledge or information, right? So it is like the knowledge or information used to be the most important part of how you think. But now this AI and everything is going to make this so easily available that just knowing this is not going to be enough. So you have to go beyond this in the days to come, in the years to come, in order to compete well in the with others. So that is one important thing I would like to highlight. So keep this in mind as much as possible, that every time just don't ask the question what is the syllabus. Also start to think how can I apply the concepts which I'm learning, and then also start to think, can I find out new problems which nobody, I mean, I've never solved before. So even if it's a problem which you have never solved before, it is an innovation for you, right? Doesn't have to be cutting edge research at the forefront of science. If it is something that you have discovered on your own, that is a small innovation. So do that as much as possible. Okay, so yeah, this was just one small point I would like to
Okay,
highlight for.
students, I will like to interrupt Prashant for a minute. Today itself, Prashant has got a patent in one of his what we call it discovery, or
It's an invention. So
it's an invention.
yes.
Okay, so we congratulate him, and if you can brief the students what it is about, they may understand what exactly you're trying to say in a couple of minutes. Hmm?
Okay, okay. I'll try to do that at the end of today's lecture. But yeah,
Yeah.
it's a very interesting topic actually.
So
So
this is his second patent in the last 10 years and almost 5 to 6 papers. How many papers are
yeah,
there?
yeah, yeah, probably maybe even
Five,
more.
5 to 6 papers are approved, and this is his internationally acclaimed second patent. So he is
Mm.
doing what he's trying to tell you, and that has taken him here where he is today because he did what he's asking you to do when he was of your age. Okay, over to you.
Yes. Yeah. Okay. So with that, let us continue with the questions that we would like to discuss today. So last time we were doing the topics such as we started with topics related to motion of objects like acceleration. By the way, this slide, I have to reduce the font size to fit in more points here, but hopefully you can read it. So last time we had seen questions related to basic laws of motion and force, conservation of momentum and energy. We also saw some examples of density and buoyancy in fluids. So today we are going to see questions of these three topics mainly: electricity, like electric charge, force, simple circuits like equivalent resistance of series and parallel circuits, some basic optics like how objects get reflected in the mirror or in a convex lens and things like that, and heat and temperature like specific heat, latent heat, and those concepts. So as same as what I said last time, that how you were supposed to prepare. So you have to build a solid understanding of these basic concepts. You have to have a very good ready reckoner of all the important formulae. I hope you have done that. I mean, you got 1 week to prepare for today's lecture, so I would be very happy if you have already prepared your formula sheet. If not, please do it as quickly as possible, because the earlier you prepare this formula sheet, the more easily it will become, natural part of your language. So the earlier you get exposure to these formulae repeatedly, it will be very useful. And then you have to go one step further. Knowing the basic formula is just the first step. You have to create special cases of the formulae based on all the questions that you are studying. That okay, this is the type of formula which is applied again and again. So why don't I create a special footnote that this is a special case of that formula which I would like to quickly apply and save some time. So make sure to do all of these for today's topics also. And of course, mathematics is very important as usual. So with this ideas in mind, let us start to look at the questions directly. And again, this degrees of freedom concept, again, I hope I had given a small homework to you last time, that try to list as many formulae as you can, and all the degrees of freedom that you can discover in that. So make sure to keep mentioning that wherever possible. Okay. So let us go to the question. So question 11 and 12 we already covered last time. So let us start in question 13. So now let us go to, uh, oh, sorry, looks like I did not copy the questions in my slides. So let us look at the PDF directly. Okay. So question 14, let us start with question 14. It is on electric charge. So first thing that I hope everybody knows is what is the formula for the electric force if you have two charges. Firstly, whether they attract or repel each other based on the signs, and then what is the magnitude of that force. So that is the basic knowledge that everybody should know for answering a question like this. So I hope everybody knows this. Then can you raise your hand if you already solved this question, question 14? Anybody who has already solved this question? No, that is surprising. So I hope everybody knows the formula for the how the force between two objects, two charged objects behaves. So it is the same formula as gravity. So if you have a charge Q1 and a charge Q2, then what matters is the distance between those objects. So if I call the distance as R, so then the force is given by the product of the charges upon R square times a constant, which is the Coulomb's constant, right? Here I'll just show it as capital C. Okay. So basically, in terms of direct and inverse proportion, you can see that the force is directly proportional to the magnitude of the two charges, and it is inversely proportional to the square of the distance. So if you know the equations of gravity, it is exactly the same. Like this, instead of Q1 and Q2, there could be two masses. So it could be like a sun and earth. Okay. So they have the masses and the distance between them. So the force of gravity is given by a very similar equation, that the mass of the first object into mass of the second object upon the distance square times the gravitational constant. So, in fact, as you study more advanced physics, you start to realize that this similarity between electricity and gravity goes much further than just this first equation. Many concepts, many formulae are very similar in both the cases. Okay. Only one slight difference is that here you have to take signs into account. So whether these are positive or negative sign, that will not change the magnitude of the force, but that will change the direction. So I think we all will know that opposite signs will repel. Sorry, opposite signs will attract, right? So positive and negative forces will attract each other, and positive forces will repel each other, and negative forces will also repel each other. So these two things together will give you the force and the sign of the attraction or the repulsion. So this is all the knowledge you need to really solve this question. So let me go back and read the question, that what is it saying exactly. So what is given? Q is a positive number. Charge of single electron is given to be some minus q coulomb. So why minus q? Because by convention we say electron is negatively charged. Okay. So we should start to draw the diagram of this. So there are two stationary and electrically neutral particles x and y, which are 1.5 q meters apart. Okay. So what does a diagram of this look like? That you have to draw the two particles x and y, right? And initially the charge is zero, right? So charge is zero because they are given both to be neutral. Okay. And the distance between them is given to be 1.5 q meters. Okay. Then what is given? Now n electrons move from x to y. So when one electron moves from x to y, right? So one electron, if I show it as a small dot and with the E minus sign, so minus to show it's a negative charge. So when one electron leaves x and goes to y, what will happen to the charge? Will the x become more positively charged or negatively charged? And what about y? So when one electron leaves x, right?
Positively charged, whereas Y will become negatively charged.
Yes, correct. X will become positively charged because why? Initially it is neutral and a negative charge is leaving. So therefore, whatever will left, and you can think of it as a pair of proton and neutron, right? So if a pair of proton and neutron are both present, the total charge is neutral. As soon as the electron leaves, whatever remains will be positively charged. So if one electron travels, then x will, and we know what is given. We are given the charge of one electron. One electron is minus q coulomb, right? So after one electron goes from x to y, the new value of the charge of x will be plus q and y will be minus q, right? Because one electron has arrived at y and one electron has departed from x. But this does not happen for one electron. They have said this happens for n electrons, right? So totally at the end of all the electrons traveling, what will the picture look like? How much total charge will be at x and how much total charge will be at y?
At x it will be plus nq and at
Yes,
y it will be minus nq.
correct. Correct. And so first thing you'll notice is that initially the entire system was neutral, right? The total charge here plus total charge here was zero. And that is conserved here. So total charge will always be conserved. That is one of the basic laws of conservation, that you cannot create or destroy charges. So as a result, the total is zero and x has gained a plus positive charge of nq and y has a negative charge. Yes, somebody raised their hand. Any questions? No. Okay. So then now we know the charges and we know the distance between them. So all we have to do is apply the equation, right? So what will the equation say? That what is the magnitude of the force? So first we have to figure out the magnitude as well as the direction. So firstly, can we look at the signs and establish that direction has to be attractive, right? Because these are unlike charges, so they will attract each other. So the force is clearly attraction, but how much is the magnitude going to be? So it is going to be that Coulomb's constant, which is given to be 18 into 10 raised to minus 2, right? 18 into 10 raised to minus 2. And I won't write the units here because they have nicely aligned everything to the MKS system. So everything is in newtons, meters, coulomb. So I don't have to worry about the units here. Into the product of the two charges. So the first charge is NQ. And here I'm only going to take the magnitude because we are going to handle the sign separately. So here I'm just going to take the magnitude of the two charges. So NQ into NQ upon the distance square. So distance is 1.5 Q square. And this force is given, right? How much is the force given to be? 288 Newton. Right? So this is equal to 288. And now first thing you'll observe is that in this equation, Q is going to cancel. So we were not given the value of Q, but we don't need it also, right? Because here Q from the numerator and this Q square from the denominator is going to cancel. And so now it is just simplification and we have to find the value of N. So clearly N is the only unknown in this equation and we can solve it, right? So I'll just quickly write the steps. So I'll keep N square on this side and take everything else to that side. So I'll get 288 into 1.5 square and the denominator I'll get 18 into 10 raised to minus 2. Okay. This 10 raised to, denominator 10 raised to minus 2 can be taken to the numerator and converted to 10 raised to 2, that is 100, right? So this is nothing but 288 into, sorry, 2.25 into 18. Okay, so I think many things will cancel. So I will get and yes, so n square is this. So n will be just the square root of that, which is 60. So n is 60. So which means that there are 60 electrons going from x to y, right? But now read the question carefully because they have not asked the number of electrons directly. See, they have added one small twist that instead of asking the number of electrons, they have asked that if the force is attraction, then write n plus 1. If the force is repulsion, write n minus 1 because they want to find out that also. See how they pack two questions in one question that if you just find the value of the electron, the force or the number of electrons, but don't know the sign, then you cannot solve this question. But now we know that it is attraction, so we have to write 60 plus 1, correct? So the final answer is 60 plus 1, which is 61. Okay, so I'll just pause for 1 minute if you want to copy anything. And what was the tricky part of this question where somebody might make a mistake was just the sign. I think that when one electron goes from x to y, whether x becomes positive, y becomes positive, that could be the small point of confusion. Otherwise, this is a direct application of the formula which all of us should know. There is nothing more than that.
Sir,
Yes.
I have a question, sir. How have you taken the distance is 1.5, right? So how have you taken as Q? Or you just
It is given, right? The distance is given 1.5 q. So important to note, q is not does not
oh
have
okay,
any
okay.
unit. Yes, q is just a number.
Yeah.
Yeah, but yeah,
Oh,
it is
okay.
given.
I thought Q was the unit.
Okay. Okay. So if no other doubts, we can go to the next question. Question 15. So what about question 15? There is a circuit given, and we have to find the current passing through the battery. So the most important principle of any question like this, and this is a general principle we should all remember, okay? Anytime you're trying to solve a question, you know the concept of equivalent resistance. What is the benefit of equivalent resistance? Is that you don't have to think about those individual resistances, right? You can think of all of them combined as one single big resistance. So that is how the problem gets simplified. So at all the time, whenever we see a chance to simplify the problem, we should do that. Okay. So we have to start thinking that how can we simplify this problem? Like which parts can we, remove from the diagram, things like that. Okay. So let us draw this circuit first. So somebody is not muted. Can you please mute yourself? I see some background noise. Okay, this is the diagram which they have drawn, and they are given the values of the resistances. So 16, 35. All the resistances are in ohms, so I'm not writing ohm every time. And the battery is given to be this much. So can somebody tell me that if you want to start simplifying this diagram, where will we start? What is the first thing that you will notice about this circuit? That this part is easily we can replace with something simple.
So we can add that resistances in series 10 ohm, 10 ohm.
10 ohm plus 10.
So that 10 ohm is in the short circuit, so we can cancel it.
Notice what is this like? This is a short circuit, right? So this point is connected to this point directly. So the voltage across this resistance will always be zero. So no current is going to flow through this resistance. So we can remove it completely, right? Or another way of you want to think about it, if I just draw that part of the diagram separately, you can think of this as two resistance in parallel, 10 ohm and 0 ohm. And I mean, although you cannot divide by 0, if you do those calculations, effectively you will see that the total equivalent resistance of this circuit is 0 ohm. So effectively this 10 ohm resistance will not have any effect at all. Okay, so I can just delete that part of the diagram. So I will, ideally you can, draw a new picture, but that will take a lot of time. So here I'm just going to ignore it for now. Okay. So basically just think that this 10 ohm is not there. So what that means that this point is connected to this point directly, right? Like this, right? There is no resistance in between. Okay. So now if that one resistance went away, can we get rid of any other resistance? Can we apply equivalent resistance formula anywhere?
Two
What?
remaining 10 ohms are connected in parallel.
Yes. So one thing about circuits is that you are free to move the points as long as you don't change the order. What do I mean by that? So this point is connected over here, but just imagine that I take some scissor and I cut this wire. Okay, so I cut this wire and I redraw the diagram like this. So I've just changed the position of that connection from this point to this point. But if you think about it, that does not change anything because these two points are just one continuous wire. So I could put this point anywhere on this wire, it does not matter. So I am free to redraw the circuit to make it simpler to understand. So if I do this change, now does everybody notice that these two 10 ohm values are in parallel? And so if they are in parallel, what will happen? I mean, again, you can write the equations and compute it, but I think by experience you will know that when two equal resistance are there in parallel, they basically become half, right? So they will be replaced by one 5 ohm wire. So now let me draw the new diagram after these two steps of simplification, immediately you see that the diagram has become much easier to follow because now what is remaining? We still have the 60 ohm resistance, the battery is there. We have this 35 ohm resistance at the top. And now these two 10 ohms have become one single 5 ohm. So you see immediately compare this diagram to the original diagram where so many things were happening. Now it is much more simpler to navigate and find out what is happening. So now I think we all can see that how to continue. We can combine these two in series, right? 35 plus 5. So these two together can be replaced by one single 40 ohm circuit. So again, let me draw it. In exam, keeping on drawing it again will take a lot of time, but here just for illustration, I'm doing that. So this is a 40 ohm and this is a 60 ohm. Okay. And again, these two are in parallel. So now they may not appear in parallel, obviously in this diagram. But again, the principle is I can rearrange this circuit anyhow I want as long as I don't change the position of the connection. So in other words, what I can do, if I, delete this junction from here and here, okay, and I just, pick up this 40 ohm element and place it like this. So all I've done is taken it from the right side and placed it to the left side. And obviously left or right will not change the values of the current or anything, right? So now as soon as you rearrange the diagram like this, now everybody can see that it is actually two parallel resistances. So don't let the geometry fool you. See, in the electric circuits, the geometry is not important. Whether you draw the wire of 1 meter or 10 meters, it is not going to make any difference. At this scale, by the way, it is not true. If you keep making a wire longer and longer, if somebody makes a 10-kilometer wire and they think it behaves the same way as 1 meter, that is not true. So after a certain point, you start to run into other problems, other effects. But at the small scale, we don't worry about these things. So freely rearrange the geometry anyhow you want to make the diagram simpler to understand. And so the last step here is we just want to combine this, right? So total equivalent resistance will be 1 by 60 plus 1 by 40. And so that will be 5 by 120, or that is 1 by 24. So R is 24, right? And so what is R? Finally, after all this simplification, the final diagram is looking just with single resistance. And the voltage is given 312. And so now we can find the current, 13 amperes. But you see how step-by-step simplification is the crux of this problem. Starting with a complicated circuit, how we got rid of one element at a time to simplify it to just one single resistance. So learn the pattern that how we are supposed to do this successive simplification. Any questions? Okay, I'll just wait for 1 minute. Okay, so this was question 15. So these were the two questions on electricity from this paper. We also have a couple of questions from the next paper, but let us continue with the order of the questions as it is given here. We'll come back to those questions again. Okay, question 16. Actually question 16 is given as an optics question, but if you think about it, isn't it a geometry question? Those who have got a chance to solve it already, what do you think? Is it really optics question or a geometry question? So those who have not solved it, I'll just wait for a couple of minutes. Try to read the question and solve it now. Okay. So why am I saying this is a geometry question? Because it is all about finding angles, right? If you find the right set of angles, you will see that the question can be done without even writing a single line on paper. But let me just illustrate it on uh, my diagram, that which angles you can mark to finish this question. So what is given that this angle is 30 degrees, right? So in that angle, exactly halfway. So OP is the angle bisector. I think everybody can see that it is given that P is exactly midway between the mirrors. So what is the meaning of saying P is exactly midway? It is equidistant from the two mirrors. And I think everybody must have studied that a point which is equidistant from the two arms of an angle has to lie on the angle bisector. And in fact, I think they are given that information also. So that basically the point P is positioned in such a way that both of these angles are 15 degrees, right? And so these are the two mirrors. And now what is given is that first the image of the point P in the mirror A. So when you take the image of the point P, like if I draw a perpendicular like this, right? It has to be, if the image is called Q, right? It is called Q in the diagram. So what will happen, look at all the angles with respect to the point O, right? The point O is the center of the diagram in many ways, that everything is happening around the point O. So can you tell me how much is the angle AOQ going to be? If I join this
15
here,
degrees.
this is also
15.
be 15 degrees because why? We have congruent triangles, right? These two triangles are congruent because of this distance being equal. Like you can work out the SAS test or whatever test we are talking about. But the conclusion is that this angle is also 15 degrees. And then going further, we have to take the mirror image of one. So one mirror reflected in another mirror. So if you take the mirror OA and look at its reflection in OB, you are going to get OC. So OC is like a virtual mirror, right? But again, because OB is the line of reflection, the OB is going to be the angle bisector of angle AOC, right? So in my diagram, by the looks like I've mistaken A and B. A should be here and B should be here. Okay. So AOB, OB is supposed to be the angle bisector of that angle. So if I draw the line OC over here, so in other words, if I'm marking a different color, I expect this angle to be equal to this angle. And if this angle is 30 degrees, this angle will also be 30 degrees, right? So you see how this is a very nice symmetric diagram. You know, same pattern is going to repeat again and again. Okay. By the way, my diagram is not very nice. I mean, this AOC does not look to be 60 degrees, but we can just live with it for now. And now finally, we are going to reflect Q in this virtual mirror. So the same thing that we did to go from P to Q, we are now going to do to go from Q to R. But the calculation will be exactly the same. So now again, what will happen? This was 15 degrees. So this will also be 15 degrees. Right? So at this point, you see, we have found all the angles with respect to the central point O. That from point O, I can figure out the relative angle of any 2 points. And now what is given that this point P is moving towards O. So point P is going to travel along this line O. And at the same time, if you imagine what is going to happen to point Q and R, they are also going to travel towards point O. So everything is traveling towards point O, right? But in that process, what is the connection of P, R, and O? Can somebody tell me? What is the connection between P, O, and R? If I draw it in a different color.
They are equilateral triangle.
It is an equilateral triangle. Again, my diagram is not very accurate, so sorry that doesn't appear that way. But if you add up all the angles in between, right? So this is 15, 15, 15, 4 times 15. So this total angle is 60 degrees, right? This total angle is 60 degrees. And of course, the distance is the same. Like the distance OP, OQ, OR, they are all the same. So this is an equilateral triangle. And so if the equilateral triangle, this OP segment, when P travels towards O, right, with what is the speed given? 20 meter per second. So P is traveling towards O at the speed of 20 meter per second. So this equilateral triangle keeps shrinking, but when it is shrinking, it will still remain equilateral, right? The shape will not change. So how much will the distance between P and R reduce by? So P and R will also come closer by 20 meter per second, right? Basically, both P and R are traveling, but they are both coming closer to each other. But the distance between them will keep on reducing by 20 meter per second. So the answer was simply 20. So in fact, the answer which you are supposed to write is given in the question. This 20 meter per second is exactly the answer of this question. So again, this is going back to what I was saying at the start of the class. Is this really an advanced problem in terms of syllabus? No, these are everybody knows equilateral triangle, everybody knows angle bisector. But the advanced part is the application that you have to combine the geometry with the knowledge of mirrors and the knowledge that the equilateral triangle will shrink, all the sides will shrink at the same speed. So combining these two, three ideas is what is the difficult part. Okay, so we have to master that with practice. Okay, I hope this question is clear. And if I get time, I'll actually show this in action, where we can actually draw these mirrors. There is a software called GeoGebra in which you can actually draw this diagram and it will nicely help you to visualize. But I'm not showing it right now because, of course, in the exam, you don't have access to all these tools and you should use these tools carefully. It should not become a replacement for your visualization. Your imagination should be enhanced by the tools, not reduced. Okay, so you have to use the tool carefully, but we will see if we get time to do that.
Sir, can you show the answer? Can you show your screen?
Okay, you want to see the diagram? Yes. Oh.
Yes.
Yeah, actually what happened, my original angle AOB, right? I took that as 30 degree, but that is a very large angle here. I should have taken it smaller so that the entire diagram will look to scale. So the diagram is not to scale right now, but you can still work out the calculations.
And sir, why will the equilateral triangle shrink?
See, the triangle will always remain equilateral because we did not take the point P as any special point. Oh, it was only on this bisector, right? So any point on this bisector where P could lie anywhere on this bisector, its image R will always form an equilateral triangle, right? So it is always going to remain an equilateral triangle.
Okay, sir.
Yeah. Yeah, but really, if we can draw that in GeoGebra, that will help you to visualize. So we will try to do that by end of this class. Please remind me in case I forget. Okay, question 17. Okay, so for question 17, one important formula you should know. I don't know whether it is covered in the school textbook or not for all the boards, but do you know the relation between the distance of the original object and the image of the object? There is a formula, right? DO, DI, the focal length.
Yes,
Uh,
sir.
No, no, sir.
some of you don't know it. So let me write it. Okay, so this is an important formula. 1 upon DO plus 1 upon DI is equal to 1 upon F. So here DO is the distance to the original object. Okay.
So this formula is there. in all
Yes,
the-
sir.
Yeah,
This formula is there.
yeah, but maybe I don't know if all boards have it. So I'm just writing it for your reference. Okay. Distance to the image. So this formula is applicable for convex lens, even for concave lens, but there the signs are slightly different. But basically, it's the same formula. F is the focal length of that lens. So these are the three important distances in the diagram. And by the way, if you somebody may know the formula but don't know the proof, the proof is actually again a piece of geometry only. Actually, all the optics that you do are in a way it is just geometry applied in some way. So it is not really a very different topic as such. So basically, if you know the distance of the object from the lens, oh, by the way, yeah, I did not mention distance to from what? So distance from the lens, okay? So we are always going to measure the distances from the lens, okay? So just to draw illustrative diagram of what, let us say if you are talking about convex lens, what the diagram may look like. So for example, if your object is over here, okay, so this is the object, okay, which is getting projected through the lens. So maybe the ray travels like this, and let us say the image is got getting formed over here. Okay. So in this diagram, DO is this distance, distance from the lens to the object, and DI is the distance from the lens to the image. Okay. And focal length I'm not showing in this diagram, but it will be there some.
Sir,
Yes.
this is the formula for mirrors, right? For lenses, it's 1 by V minus 1 by U.
Uh, okay. Actually, I think the same formula can be applied by just changing the sign. So I don't know. Maybe the version which you know is slightly different from the one which I know.
So
But
the length formula is different from mirror formula. It's 1 by V minus 1 by U equals to 1 by U.
okay, so you are saying 1 by V minus 1 by U is equal to 1 by F. This is the formula for lens, and
Yes,
this is
sir.
the formula for mirror. Is that what you're saying?
Yes. Yes,
Yes,
sir.
sir. Yes.
Okay, okay, that could be the case. I also didn't know that. But surprisingly, then I solved this question using this formula and I got the right answer. So I thought I had the right formula. But okay, thanks for the clarification. Then let me just think and see if. So here, what is V and U? Can you clarify? What is V? What is U?
V is the image distance and U is the object distance.
Distance. Yeah.
Yes, sir.
Okay. See, I don't know about this formula. I will have to check that why this formula is given. Uh, if you think about it, right? The only difference between this formula and this formula, if you see, is just the sign, right? It is like if instead of minus 1 by u, if it was plus 1 by u, right? It would become this formula. So the only difference is the sign, right? This is plus, like this, you have taken it minus here, and I have taken it plus over here. That is the only difference actually. So I think, uh, do you take the v and u as sign distances in your formula?
Yes, sir. We use the
Ah,
second.
Yes, sir. We have to use sign convention.
Okay, okay. So because you are taking the sign convention, you are getting this formula. Yes, I agree. Yes. So what you are saying is correct. This is the correct formula, you taking sign into account. But for this particular image, right, when one object is like one object is to the left of the lens, one object is to the right of the lens. So automatically one is positive, one is negative. So that is why this formula works. But I agree with you that we should remember this formula. Okay, so I'll make this correction. So so for lens, what we are saying is 1 by v minus 1 by u is equal to 1 by f. So where v is the distance to the image, u is the distance to the object, f is the focal length. But very importantly, these are all signed quantities. Okay. So those who are seeing this for the first time may get confused that there are two formulae, which one we should use. So I, at least for this question, I'll make it simple that luckily the question is such that, this formula works very well for us, that you can use DO, as I shown in the picture over here, and it will give you the answer. But if you are dealing with more complicated cases, right, where both the object and the image are on the same side, I mean, your question is how will that happen? But that happens in particular cases for some particular lenses. Okay, so for that cases, this is the more general formula to remember. Okay. For now, let us solve this question with this formula only, because that is what I am more comfortable with for now. So what is given? What is given is that the object is at a distance from the lens. So the setup is like there is a screen, there is an object, right? So the object is over here. Let us say the screen is over here. Okay, and the lens is initially, let us say the lens is at some position like this. Okay, so we can call these distances x and y. Okay, and so what is given is that the object forms a sharp inverted image on the screen, right? So basically, the object is going to form an image on the screen. So at this particular distances, what we can say is that the values satisfy the lens equation. So 1 upon x plus 1 upon y is equal to 1 upon f. Again, I'm using x, y, the positive version, because I'm ignoring the signs over here. So this is the first equation that you get. Now what is given that we move the lens towards the object by 15 centimeters. Okay. So now new picture which is given is that the position of the object is not changed. The position of the screen is also not changed. Only the lens is shifted by 15 centimeters, not meters, sorry. So, and again at this point, once more a sharp image is formed. So, which means that this new distance, right? So, this new distance is x minus 15, and this distance is y plus 15. That is also going to satisfy the same equation. Okay, and the focal length of the lens is given to us, right? F is given as uh, 10 centimeters. Okay, so yeah, now this is just if you replace f by 10, this is just a system of two equations and two unknowns, right? So we should just solve it as a simultaneous equation. So 1 upon x plus 1 upon y is equal to 1 upon 10 is the first equation, and 1 upon x minus 15 plus 1 upon y plus 15 is equal to 1 upon 10 is the second equation. And so just rearranging and substituting, you will get the equation. So what will this give us? 10x plus 10y is equal to xy. And what will this give me? Y plus x. Okay, so we have these two equations, and because what are we supposed to find out? We are supposed to find the initial distance between the object and the lens. So we are interested in the distance of the object from the lens, which in other words, we are interested in finding the value of x. The in the original diagram, this x is the unknown we want to find. So as far as possible, we should try to eliminate y, right? Whatever is the unknown we want, we should keep it. Otherwise, we just have to add one more step in our calculation. So as far as possible, we try to keep the yeah. So if I just rearrange this equation, I can write it as keeping y to one side. What I can write it as 10x is equal to y times x minus 10. And this equation, if I simplify, I can see that 15 and this 5 will cancel and 5x will remain. And this minus 15 will go to the other side and become 25. So this equation is 25y is equal to xy plus 5x minus 225. Right? Again, here I'll keep y to one side. So what I've done here, if you notice, I've isolated y on both sides. So my plan is I can equate them, right? I can say that y is given by the same expression on both sides. So I can say y is equal to 10x upon x minus 10 from the first equation, and y is also equal to 5x minus 225 upon 25 minus x from the second equation, right? And so now the middle term y I can get rid of it and directly cross multiply. So going to get an equation purely in x. Okay. And here let me see if there is a way to simplify it before I proceed. Like for example, I can see that here I have 10, which is a factor of 5, and here also there is a factor of 5. So I can cancel one factor of 5, and what I'll get is 25 minus x times 2x is equal to x minus 10 times x minus, I have to divide this by 5, right? So I'll get 45. Okay, so 50x minus 2x squared is equal to. Okay, so finally I'm going to get a quadratic in x. Well, these are just calculation details, but doing this carefully is very important. So that is why I'm showing it to you, that how you can rearrange it in careful way. And especially doing it in a limited amount of time is important. So now I can factorize this as minus 30 minus 5. So I'll get x is 30 or x is equal to 5. But again, if you think back to the diagram, I because initially the lens is kept at a distance of x, right? The lens is kept at a distance of x from the image, the object, and then I want to move it 15 centimeters closer. So if originally x is 5, then the 15 centimeter will take it to the left of the object. So therefore, we should discard this solution and take this solution. So the answer we expect is x is equal to 30. Again, as usual, the question comes up, what is the meaning of this x equal to 5? Like if you take it the lens to the left, you are going to get minus 10. What does that mean? Like those are more advanced questions for you to think about, but this question can be solved in this way. Okay. I
Sir,
don't know
I
if
have a
this.
doubt.
Yes, go ahead.
Sir, can you just scroll up your screen? Yes, sir. In this process, in this step, 10 y plus 10x equal to xy minus 15y plus 15x minus 225.
Yes.
So here 10y plus x, we know that it is xy. So we can just cancel out the xy and we will again get a simultaneous.
Oh, yes. Yeah, that is true. I completely missed that. That is true. Even I was just going to ask that, does somebody have a shorter method? Because we know so many calculations. What you pointed out is very correct. We can just substitute this directly over here, right? So here what is given 10x plus 10y is equal to xy plus something something. But if this part is equal, that will just cancel. And so Just let me quickly write that. What will that look like on one side? So that will directly simplify this to 0 is equal to minus 15y plus 15x minus 225. Yes, I think this will lead to a faster solution. I also agree, because now again 15 is going to cancel from the equation, and what we are going to left is with, so 15 is equal to x minus y. So yeah, so now you can consider solving this equation along with this equation maybe. Okay, so substituting y from this equation into this equation is faster, definitely. Yeah, thanks for pointing that out. Yeah, but anyhow, I mean, after this is all in the step two, right? Of what I've shown in the start of our session last time, that once you convert it into mathematical equation, finding the solution efficiently is the maths part of it, is not the physics part of it. Okay. But I hope the physics part is clear, that how moving the lens, you are just getting two separate configurations which satisfy the same equation. And so those who are comfortable with this version of the formula, that is fine. You can use this version, just that you will have to take some distance as positive, some as negative carefully. But I think the overall approach does not change that much. Yes, Kana?
So how is the image distance in the second case equal to y plus 15 only?
Because the original distance was y, and the image is formed on this. So what is given is that the screen is the same, right? So again, a shaft inverted image is formed on the same screen. So the screen is not moving, right? So, and if the lens was moved 15 centimeters, then the distance which was originally y will increase by 15. So it became y plus 15. And this distance which was x will reduce by 15. So it became x minus 15.
Yes, sir, got it.
Yeah, because the total distance from the object to the screen has to be x plus y originally, and here also it is x plus y, because this minus 15 plus 15 will cancel. Okay, so this was question 17.
Hello, sir.
Yes,
Sir, is there any way after the session can you send these notes which you are writing on this?
I can send you this note. Yeah, that is no problem. Sure, but I mean, to be honest, I don't write in a very nice way. So if you're able to follow the notes, I don't have any problem. I can send it.
Yes, sir, please, sir.
Okay, no problem. Okay, then let's go to question 18. So question 18 is on a different topic now. It is specific heat, latent heat. How temperature and heat are related. That is what this question is about. So in a question like this, the most important sentence, because of which the whole question works, is this sentence. All of it is kept in an insulated container, because what that tells you is that no energy is going to enter or leave the system, right? All the heat that is going to, transfer from one object is going to go directly into the other object. So like the heat lost by one mass is the exactly the same as the heat gained by the other mass. And so wherever that reaches an equilibrium, that is your temperature. So as such, I think this kind of question can be easily solved in just one equation, because what if I just denote this by diagram, like initial diagram. So what is the initial state, that we have the cobalt block, and you are given the ice, right? Ice, ice. So you are given the masses of both of them. This is 225 gram, and how much is this given to me? 100 gram. You are given the temperature of this 410 degrees Celsius, and this is given 0 degrees. So this is the initial diagram. Then what will happen, because this is clearly so much hotter than this will cause the ice to start melting, and presumably all the ice will melt, and at that point it has become water, and after that the temperature of the water will keep rising, and the temperature of the cobalt will keep falling, and what will the final diagram look like, that they have both reached some equilibrium temperature, like the cobalt and the water, they are both reached some temperature, which let us call it x degrees Celsius. Okay, so we have to find this value of x. And so the only thing we need to find out is for the ice to reach this state, how much heat it has to gain, right? And that has to be exactly the same amount of heat that is lost by the cobalt block. So the gain in the heat over here has to match the loss of the heat over here. So if we just equate these two, we will get the answer, right? So how much is the loss of the heat for the cobalt? That is the easy part because there is no question of latent specific latent or nothing like that. So loss of heat of the cobalt block is simply going to be the difference in the temperature. So 410 minus x degrees times the mass times the specific heat capacity. So the specific heat capacity is given as 0.1 calories per gram degree Celsius. Again, you'll notice that all the units are nicely given where mostly I don't have to do lots of conversion. So I'm just not going to mention the units here, but in a different question, you may have to be careful. So the loss of heat of the cobalt is here and the only unknown variable is X. In the same way, the gain of heat of the ice slash water will be how much. So first I need to measure how much heat is required to convert the ice into water, right? Because we know how latent heat works, that without increasing the temperature, just the conversion of the solid into liquid is going to happen. And that heat is given as 80 calories per gram. So our 100 grams of ice into 80 calories per gram. So this is the number of calories required to just do the state conversion. After it has become water, then its temperature will rise from 0 degrees to x degrees. So there the temperature rises x degrees into the mass of your water, 100 grams, into the specific heat, which is 1, right? And so we are seeing that these two have to be equal. And so the only unknown variable is x over here. So just we have to solve for x and get the answer. So the equation we expect to get is 410 minus x into 225 into 0.1 is equal to 100 into 80 plus 100 into x. Okay, so we can just solve this in a straightforward way. So, get
So why we have taken their 100 into 80?
100 into 80 because we have 100 grams of ice and the information given is the latent heat of fusion is 80 calories per gram. So each gram will require 80 calories to become ice into water.
Huh.
So total 100 grams will require 100 into 80, that is 8000 calories.
Yes. Okay, sir.
So 410 into okay, so again taking x to one side, I want to get 1225 122.5 x is equal to this is how much. So 9225 minus 8000. So you see again how the numbers are nicely aligned. So on the left hand side, I'm getting 1225 is equal to 122.5x. So therefore, x is 10, right? So therefore, basically at 10 degrees Celsius, the system is going to reach the equilibrium. Okay. I'll just wait for 1 minute.
Sir, I have a doubt.
Yes.
So if the temperature was more than 100 degrees Celsius, so it would convert into steam. So do we have
Yes.
to take that also into account while we are calculating?
Not for this entrance test because at this point you are supposed to apply only one step at a time. But certainly in a harder question paper, you can have those complicated situations that, for example, there could be a case where so much heat is required that the all of the ice does not become water also. Before that, the cobalt reaches 0 degrees. That could also happen. There could be a case what you are saying that the ice becomes water, the water boils into steam, and the equilibrium temperature is somewhere above 100 degrees. So all those cases you have to consider in a more complicated question. Uh, Here, typically, there will not be so difficult problems for this entrance test. But it is good that in your mind you are prepared for these possibilities. So typically, if you get some nonsense value for x, right? If you start to get x equal to -5, -10, then if you clearly know something is wrong, then you have to think of those possibilities. But if you are getting a nice answer like 10 degrees Celsius, then there is no reason to suspect any issue. Okay, so I hope this question is clear. So again, before we go to the next paper, just take an overview that what are we applying in each question. See, always the physics part is small but important. That one small step, realizing that the thermal equilibrium, there is no transfer of heat or energy outside the system, means that the total heat released by one object is absorbed by the other object. Once you understand this principle, writing the equation is not the difficult part, and solving it is also not the difficult part. So overcome that first stepping stone. Every question has that one small sort of stumbling block, I'll say, where you may get stuck. But once you clear that, it should be easy to do. Okay, so make a careful note of these, whatever you are learning from this. So I think we are right on time today. We have exactly finished one paper and hour. So we'll go to the next paper right away. So, so next paper again, I think the topics are exactly the same in the same order. So it starts with electric charge. Uh, so again, I'll wait for 1 minute. You can think about this question before we start to discuss.
Sir,
Yes.
will you please explain question number 13 once again?
Question number 13 on of this one.
Yes, sir.
Okay. So we had discussed this last time, and what we had said was the. In fact, let me see if I have the notes from that lecture. I can quickly show it on that. No, I don't have the note, but we can draw the diagram again, not a problem. So, question 13. Basically, what we know is that wood is lighter than water. So the wooden block will float in the water. And as soon as you keep the metal block, it will start to sink up to the point where it reaches the equilibrium. That is the buoyant force acting on that particular object is equal to the mass of the force of gravity. So the diagram was, if I remember correctly, it used to look something like this, that the wooden block will go completely underwater, but the metal block will be somewhere here. And I think we had found the answer that it exactly floats halfway. So we had calculated a total force of gravity and a total buoyant force, and we have to equate them, right? So total force of gravity does not depend on how much of the portion is dipped underwater. It is just going to be the mass of the, so you can calculate density and all that. So the total mass of the wood plus mass of the metal block into gravity. So this is going to be the force of gravity. And the buoyant force will depend on how much volume is submerged. So you have to find this volume of the submerged part, and that into the density of the water will give you that force. So there, this was the variable we had introduced, that if I call this x, right? So then the total volume will be the volume of the cube, the wooden volume plus the metal volume, but only this part, right? So we have to take the cross section area, right? So if you know it is 20 cross 20, so 20 into 20 into the submerged height, which is x. So this was giving us the total volume submerged of the object. And so this will give us this term, that what is the buoyant force. And then when we equate this to the only variable which is going to remain is x, and we had found the value of x as, I think it was 10. So that therefore exactly half of the metal block was submerged. Okay, you can give it a try. Hopefully, I think you will get the calculations. If you get stuck, you can maybe ask somebody to explain. Okay. Okay, so coming to today's question, question 14. So again, it is a direct application of Coulomb's law, right? It's just calculating the force of each charge on that point B. So how the forces of A, C, and D, how are they all going to act on point B? And what is given is that the net force is zero. Again, always there will be one line which is the important part, that the total sum total of all forces acting at B is zero, and that is what is going to help us solve this question. So if I draw the diagram, it is going to be something like this. That so A,
Tikrodde
B,
malavi.
C, D are ABCD are located like this, and the distance between them is, so the important thing is distance between them is not given because it is going to cancel anyway. It is equally spaced is all that matters. So we can just conveniently assume the distances as all one. Okay. So we'll take the distances as all one, and we are given the values of the charges. So A has plus Q1 and C has minus Q1, right? So this has plus Q1, minus Q1, and D has plus Q2. Okay. And so we have to find out what is the sum total of all the forces acting at the point B. Okay. And so typically the way we do it is that imagine that at a point B there is a small positive charge plus Q located at point B. And then for that small positive charge, let us compute the sum total of all the forces. So first thing, will the force of A attract or repel B? Will it push it to the left or to the right?
Repel, right? Because
It will repel,
positive.
right? So it will go to the right. So if I have to draw it an arrow, it will look something like this. So it is going to repel. What about C? C will attract B, right?
Yes, sir.
Attract,
And
yeah.
again, so it will attract to the right. So FC. And in fact, if you see the by symmetry, the FA and FC will be same in magnitude because only the distance from B is the same. The charges are same. Everything is the same. And finally, D will repel. So D will repel the object to the left. So the expectation is that the sum total of FA, FC, FD, all of them have to be equal to 0, right? So now we just have to write the equations. So the magnitude, so here I'm just going to write the
Sir,
magnitude. Yes,
can you please repeat it?
okay. So we are going to look at it one charge at a time and see what is the effect at point B. So first consider the pair A and B. So A and B will repel each other, correct? Because they are both positive charges. And so the if I show the force of A as a vector, it is going to be a arrow to the right. So this is the force due to point A. Then what about point C? Yes, point C is negatively charged and B is positively charged. So C will attract B, right? So C is going to pull B towards itself. So again, the vector of the force is going to be towards the right because of C. And finally, what about B and D? So B is positive, D is also positive. So D is going to repel B. So D will try to push B to the left. So that is why this third vector of the force of D as shown as an arrow to the left.
Sir, is it given that B is plus is
No,
positive?
we are just taking a small charge over here and we are calling it plus Q. See, if you
But
take instead of plus Q, if you take minus Q, what will happen? All the vectors will flip in direction, but the sum total will remain 0.
yes.
So whether you take it plus Q or minus Q does not.
Okay.
And in fact, that small q is going to cancel, right? When we equate the forces, everything the q is that small q is going to cancel out. So firstly, how much is the magnitude of FA and FC? So it is going to be the Q1 times Q upon distance square. So distance we are conveniently taken to be 1, so 1 square times the Coulomb's constant, which I'm again we don't use the same letter, but I'm going to show it as capital C over here. Anyway, that constant is also going to cancel out, so it doesn't really matter. So this is the force due to A and C. And what about the force due to D? So note that D is at twice the distance. The distance from D to B is 2. So keep that in mind. So the magnitude will be Q2 times Q upon 2 square. Again into the Coulomb's form. And so
What you
the in terms of magnitude, we expect FA plus
Right.
FC is equal to FD. Yes? Anybody's asking anything? Okay. So in this equation, see what is going to happen. So FA plus FC has to be equal to FD in magnitude, right? So again, so first thing you'll notice is that C is going to be cancelled from all the three parts and small q is also going to get cancelled. So I'm not going to write it. Okay, so we can just directly write Q1 upon 1 square, which is simply Q1, so is equal to Q2 upon 4. And what do we have
sir,
to
how
find?
have you
Yes, what are you asking?
sir, what have you taken as C as in you just made it a unit, okay?
C is the Coulomb's constant, right? We don't know the value. We don't even care about the value.
Sir, how F1 plus FC is equal to FD?
You're asking about this equation?
Yes, sir.
Because it is given the important statement, right? The net force is 0. The total force of A, C, D together at point B is 0. So the total force to the right, like the A and C are going to push the point to the right, and D is going to push to the left. So that sum total of the forces going to the right are this term, and sum total of the forces going to the left are this term. So they have to be equal, right?
So why we have taken that 1 times Q?
Which line are you referring to?
F1 is equal to Fc is equal to Q1 times Q by 1 square.
This, right? So what is the equation of the electric force when you have two charges, Q1 and Q2, and you know the distance? What is the force due to electric charge? It's the Coulomb's constant into the product of the charges upon the distance square. So that is what we are applying here. I hope everybody knows this formula. I
Yes.
mentioned it at the start of today's lecture also.
Yes.
So now, if I simplify this, I'm just saying 2Q1 is equal to Q2 upon 4, or in other words, 8 times Q1 is equal to Q2. And what I'm supposed to find is the ratio Q2 upon Q1. So Q2 upon Q1 is 8. Right? So this question may appear complicated at first because there are no numbers involved. Everything is being done in terms of variables, and some variables are being introduced, some are getting cancelled. But don't get confused by all of that. Finally, what we're applying is very simple. We are just calculating the force due to three charges and adding them to be 0. So that is all that we are doing. And there again, wherever possible, we have simplified things. Like instead of taking these distances between the points as some another variable d, we just call the distances as 1 for our convenience. So we can do some small simplifications like that wherever possible. Okay, so we'll move to the next question. Okay, question 15. So what is given is that the same resistances are connected in two different formations. One is in parallel and one is in series. So I think one very good way of trying to write this question is you can make two columns. Okay. So column 1 for the first situation and column 2 for the second situation, and we can compare it, right? So let us say the first column is the parallel column. So this is the case when the resistances are in parallel, and this is where it is in series. And what are the values of the resistance? R1, R1 and R2, right? So first thing you have to find out what is the equivalent resistance in both cases. So like here, if I write it as Rp, then we know that the formula is sum of the reciprocals, right? And the series case, Rs will be just the sum. Okay. So one thing I'm going to do here right at the outset is, see what is the question asking us to finally calculate the ratio R2 upon R1. So we want to get to that ratio, right? So why are we writing R2 and R1 separately all the time? I'm going to call this ratio as some another value X. Okay. So I'm going to introduce a variable, let the ratio be given by x. Okay. So therefore R2, instead of writing R2 every time, I'm just going to write x times R1. Okay. You'll see why this is important, because then, nicely R1 is going to cancel and I'm going to get very nice equations at the end. Okay. So that is why I'm doing the simplification. Okay. I'm just going to write it as,
So you've written R1 plus R1 plus R2, right?
this is R1 plus R1 plus R2 is correct. Okay. So now, if I simplify this in terms of this, right? So instead of writing R2, I'll always write x times R1. So this is going to be R1 times 2 plus x, right? Because R2 will be replaced by R1x and R1 will come common. So this is the resistance in series, and in parallel we have to take the LCM. So again, instead of writing R2, I'm going to write x times R1, right? So when I take the LCM, x times R1 square, and the numerator, what am I going to get?
So why square?
Oh, sorry, I made a mistake here. Yeah, the LCM is simply x times R. So I want to get x plus 1, right? And so if I take the reciprocal, because I am interested in the parallel resistance, so that will be x times R1 upon 2x plus 1. So we have found both values, the resistance in series and resistance in parallel. And you see already there is one nice part that R1 is coming as common in both cases. Like even this I can rearrange as R1 times something. Okay. And why is that important? Because what the information given in the question is in terms of some ratios. So what is given is that, so when the heater is connected in parallel, it takes T minutes to increase the temperature of that water. And by the way, notice that the same quantity of water is involved in both cases. So the temperature increase and the quantity of the water does not change. So we can directly equate those parts, right? So we don't have to worry so much about how much is the work being done. Little more complicated question will change that also. Instead of 10 liters here and 10 liters here, somebody may take 20 liters just to confuse you. But this is kept deliberately simple. And so the only thing is that the first combination takes T minutes and the second combination takes 20 minutes, right? Which means the second combination takes longer than the first combination, right? So writing in terms of the equations of power, right? So do we know what is the formula for power? And remember that this is a household geyser. So what happens is that the voltage is going to remain constant, right? The voltage coming out of your plug socket is not going to change. So in other words, the V is constant, right? So V, the voltage is constant. And so you have several formulae for the power, but which formula should you use to take advantage of the fact that voltage is constant?
P is equal to VI.
Yeah, or how about V square by R?
V square by R, sir.
Correct. So we must be knowing all of these formula. It is R, I square R, I into V, and V square by R. So we will conveniently choose the version which gives us direct access to the information that we know. So if I use this formula, so the first power 1 is V square by R1 or RP, and the second power P2 is again V square by RS, right? And what is given is that the second case takes more time. So if it takes more time, it means that it is consuming less power, right? It is consuming 1/10 power actually. So in other words, P2 is 1/10 of P1, right? And so we have everything in place to equate and get the value of X. Now it is just substitution, right? And again in the substitution, what you are going to see is that V square is going to cancel, R1 is also going to cancel. So if I just write P1 is 10 times P2, so V square upon P1, which is RP, is 10 times V square upon RS. Okay, and now if you substitute the value of RP and RS from here, In fact, let me cross multiply first. So I'm going to get RS is 10 times RP, right? And so therefore R1 times 2 plus X is equal to 10 times RP, which is X upon 2X plus 1 times R. So again, R1 is going to cancel and we are going to get an equation purely in terms of X, right? So if I rearrange this, I'm going to get 2X plus 1 times X plus 2 is equal to 10X. And I think the roots of this are -4 and -1. So 2x minus 4 and minus of x minus 2. So therefore, when I simplified and just going to write the direct answer, I'll get x is equal to 2 or x is equal to half. So both answers are possible. But again, if you go back to the question, read carefully. What is x, by the way? We had assumed x in our solution as R2 upon R1, right? So if I keep that information in mind, again, go back to what we had talked at the start, that remember step 3, interpreting the value back in terms of the given equation. So R2 upon R1 is x. And if you read the question carefully, it is given that R2 is greater than R1. See how it was deliberately given, because the exam paper setter knows you are going to get two solutions and the student needs to know which solution to write. So exactly to give us that hint, this is given that R2 greater than R1. So R2 greater than R1 means that this is a ratio greater than 1. And so we have to take this route and not this route. And so the answer is R2 upon R1 is 2. Let me check that quickly. Question 15. Yes, the answer is 2. Okay. So again, going through the steps carefully, what we did first, what we did next. We started by first calculating the parallel and the series resistances. So we found the value of RP and RS. And to simplify our calculation, we took everything in terms of the ratio. We use this X, right? Otherwise, everywhere R1, R2 both will come and how to cancel them. Just to make things simple, it is this kind of a shortcut, you can say. And then the important information was in terms of the power, that one case takes 10 times longer to hit the same water than the other one, which means that the power involved is 10 times smaller. So P2 is 1/10 of P1. And then just using the right formula, V square by R, equating and solving for X, we get the answer. So again, I hope you are observing how all of this is going beyond just syllabus, that there is no syllabus which will tell you that this is what you're supposed to do. The application is what is getting tested here in all the questions.
Sir, can you tell why x is equal to 2 and not x equal to 1 upon 2 again?
See, the quadratic equation has both roots possible, but what the question has told us very particularly is R2 greater than R1. If you read the question, it is given R2 is greater than R1. So which means the ratio
Yes.
R2 upon R1 has to be greater than 1, right?
Okay, sir.
Okay, I'll just wait for a minute before going to the next question. Okay, question 16. Again, this is not really a optics question in the sense that there is more geometry involved here than optics. And yeah, all of us, we have done school geometry. We know how to calculate various angles. This question should be easy to solve. Can you raise your hand? Those who have already solved this question. Yes, I can see many of you have already solved this question, which is expected, right? It is just, in fact, I won't even wait to solve this question. Let us directly look at the diagram. So, what is given? That there are two mirrors. One object is placed over here. Uh, I'm just drawing the diagram very roughly because we like to finish this question quickly. So the basic thing which is that we know angle of incidence is the same as angle of reflection. But if I continue that dotted line for the virtual image, of course the by alternate angles that same angle x is going to occur here also. And same thing is going to happen here. This angle of incidence and reflection are equal, but that is also by equal by alternate angles to this much. And so in this diagram, if I label the points as per the what they are given, this is B, Q, R, T, right? Yes. So in this angle B, the angle QBR is given to be 132 degrees. And so therefore I can find x plus y in triangle BQR is going to be 180 minus 132, which is 48. And so if x plus y is 48, 2x plus 2y is going to be 96. And what is 2x plus 2y? In triangle QTR, I can find angle T is 180 minus 2x minus 2y. So the answer turns out to be 84, right? 84 degrees. So that was all that was there to this question. I mean, just geometry, really speaking.
Sir,
Yes.
of measure of angle of in center produced by the angle bisectors of two corners, that is 90 plus a by 2.
Yes, yes, you can. That is a very good observation. You can observe that these are both angle bisectors. So therefore, B is the in center. And so if this angle is A, some of you may know the formula that this angle is 90 plus A by 2. And so therefore, you can do it in even one line less calculation. That is exactly, this is exactly what we would like you to do, that create this small formulae and be prepared in advance to save your time. That instead of doing all of this, you could have done it in maybe half time. Okay, so yeah, that is exactly how you can think about these questions. Yes, Shreya? Okay, so I think we can quickly move to the next question. Question
So can you just
17.
1 second?
Okay, I'll wait for 1 second, half a minute. Okay, so going to the next question. So question 17, again, it is pretty much the similar kind of question as what we did last time. So image of the object is real and half the size of the object. And when the object is moved, the image is of the same size. So I mean, only one point to be added in the what we talked about earlier was that earlier we are talking about the distance from the lens, but here we are talking about the size of the image or size of the object. But through again basic geometry, we get a lot of similar triangles. We can see that the size of the object is going to be proportional to the distance of the lens. Why? Because all the rays finally travel through the center of the lens, right? So you get a lot of similar triangles, and therefore, in both cases, you get the same kind of formula. So again, I'm going to refer to it is not exactly the formula which you may have studied in school or anywhere, but to solve this question, it is very convenient to ignore the signs and just solve it that way. So again, what is given is that so initial position, what is given is the image is half the size of the object. So let me draw it somewhere over here. So the fact that the ray has to pass through the center is why what I was saying just now, that the instead of taking the distance of the object, you can talk in terms of the size of the object or size of the image. The equations don't really change that much. Okay, so here if I call this as the SO and SI, so instead of DO and DI, right? DO and DI refer to the distances from the lens. SO and SI can refer to the sizes of the images or sizes of the object. But the equation is going to be exactly the same. So 1 upon SO plus 1 upon SI is equal to 1 upon F. Okay. And when the object is moved towards the lens by 10 centimeter, right? So if instead of this, I draw the diagram like this. So I move the object 10 centimeters to the left. and I again calculate. So what is happening? The distance from the lens has reduced, but in the process, the image size has increased. So now what is the information they have given, that now the image and the object are of the same size. That is what is given now. When the object is moved towards the lens by 10 centimeters, its image is real and of the same size as the object. So if the size is the same, then the distance is also the same, right? By the way, I made a mistake here. I should not write SO and SI. I should write DO and DI only. But just the fact that DO and DI are going to be proportional to SO and SI. Okay. So now in the new case, same as before, if the object has not moved, but the lens has moved closer by 10 centimeters. So now the new distance will be DO minus 10, right? The original distance minus 10, right? So I'm going to get 1 upon DO minus 10. And now observe that now if the image is of the same size as the object, then the distance will also be the same. Okay. So this is what is given to us. And what we have to find is to calculate the focal length of the lens, right? So we have to find the value of f. So first thing I think we can do from the second equation, I can simplify and just write it as 2 upon DO minus 10 is equal to 1 upon f. And so if I and okay, and one more information which I did not use is that in the first diagram, one more thing is given. We know the relative size of the object. We are given that the size SI is half of the original object. So in other words, DI is also going to be half of DO, right? So in this equation where we had DI can be replaced by half of DO. So now you see again we have a situation of two unknowns and two equations. So we can solve it. So what is the first equation going to give us? First equation is going to give us 1 upon DO plus 2 upon DO, right? So 1 upon DI will become 2 upon DO is equal to 1 upon F. This is equation 1. And equation 2, which we are just writing out here, 2 upon DO minus 10 is equal to 1. Okay. And so from this equation, what we are getting is that I can replace DO by 3F, right? So I can eliminate DO and I can work with only in terms of F because that is the answer I'm looking for. I'm supposed to find the focal length. So that is why I'm eliminating DO. So therefore, what will this equation give me? 2 upon 3F minus 10 is equal to 1.
Can you take a screen above?
Okay. What do you want to see?
Irshad, can you again explain the why is the DI equals to half of DO?
Sure, because what is given is SO. We are not given the information in terms of the distances, but we are given in terms of the size, right? What is given is SO, the original object, is twice the size of the image. But do you see these are similar triangles? This triangle is similar to this triangle.
Yes.
So by similarity, if the SO and SI have the ratio 2 is to 1, even DO and DI will have the same ratio, right?
Okay.
And same reason in the second diagram, what happened? They did not give the information of the distance from the lens. They only talked about the size of the object. But if the object is of the same size, so here we are in fact going to get congruent triangles, not just similar. And because they are congruent, therefore these distances are equal.
Okay.
Okay, so now we just want to solve for f. So 2f is equal to 3f minus 10. And you are going to get f is equal to 10 centimeters. Okay. So I mean the only if you know this lens equation or whatever version you know, maybe 1 by v minus 1 by u, the only thing that is getting tested over here is your knowledge of similarity in a way. I would say that knowing that as the object and the distance from the lens are always in proportion, yeah, in a given configuration. Yeah, just wait for 1 minute. You want to copy anything?
So just one.
Yeah, okay. So when you are going to solve physics question and you may struggle with a particular question, afterwards when you look at the solution and you figure it out, go back to the question and think again that where did you get stuck? Did you get stuck at the physics concept, or you got the physics, you got the equation, but you got stuck at the mathematics solving part, or you did the solving part also correctly, but you made a calculation mistake. Like there could be three, four possible places where you struggle, right? So every student has to analyze their own pattern, that what is it that is giving you the most trouble, and then go and try to fix that. So if it is the physics concept that is giving you the difficulty, then make sure to revise all those concepts, make sure to know all the laws, all the formulae properly. If it is a mathematics part, then practice solving equation of various type. Practice solving quadratic equations, simultaneous equation involving fractions, reciprocals. Create your own equations and try to solve them. Okay, so that is how you have to create your own practice material. You cannot rely on somebody to give you the practice material all the time. Okay, I think then question 18 is the last question. Actually, and we can follow it up with question 19 and 20. Those are the two questions remaining, right? So actually, we have to cover three questions in less than half an hour. Maybe if we have to extend by a few minutes, we'll try to finish it today. Okay, so question 18. Again, you see it is a very similar question to the previous one, that the system is coming to equilibrium. Everything is in an insulated container. So all the heat which is going to go from one mass will directly be absorbed by the other mass. So we just have to find that equilibrium point. Only difference is there it was ice becoming water. Here it is water becoming steam.
So how to find the quantity of that steam? Means
See, what will happen? Think of it in terms of how the physics will work. So first, let us say all the water will reach 100 degrees Celsius, and up to that point, the solid block of metal is cooling down. After all the water has become steam, right? After, no, sorry, what is going to happen? I mean, slowly out of that water, some part will start to convert to steam. As and how that is happening, the block of metal is going to keep cooling down until the point where the block of metal reaches 100 degrees. Once the block of metal reaches 100 degrees, it cannot transfer any more heat to the water. So we have to figure out that the block of metal is going to, that is not going to go under any change of state, right? That block is just going to cool from 1500 to 100 degrees. So how much is the total heat that is going to get released in that process? And then out of that, we have to figure out how much of that heat is going to be used to convert the water into 100 degrees. And then whatever is the leftover heat, only that much steam will get generated. Okay, so just have the picture clear in your mind and then you can formulate the equation. So again, it is good to draw it like initial state, final state. So initial state of the system is like the block of metal is at 1500 degrees Celsius. How much is the mass of the block? 600 grams. Okay. And the water is at 40 degrees Celsius, and how much of that? 950 grams. Okay, so we'll draw the final state later, but before that, let us draw this intermediate picture that at some point in between, what will happen is that the water has, before it starts to become steam, right? The water is just going to become 100 degrees Celsius water without going through any change of state. So for this to also happen, it has to gain some heat and the block of that metal is going to lose some heat in the process, right? We don't know how much we can calculate that, but what I'll suggest is we don't need to. But we understand that the block of metal is going to cool down by some temperature. And then after this, what is going to happen? What is the final diagram going to look like? The final diagram will be there will be some water, there will be some steam, right? Not all the water has become steam. So there is some water and some steam and the block of metal. So all of them are at an equilibrium of 100 degrees. So again, writing the equation. So first thing is total heat lost by the metal. Let us calculate this first. So the total heat lost by the metal is simply the change in the temperature, right? Delta T, which is 1500 minus 100 degrees, right?
Sir,
Yes.
sir, how did you get the equilibrium to be 100?
So that is, we are making a assumption because the question is saying calculate the mass of steam present. See, if it were the case that all the water has become steam, then the mass of steam is just going to be the mass of water, which is 950 gram. But we know that the answer cannot be 950 because that is outside of 00 to 99 range, right? So only some of the water is going to become steam, right? But that is an assumption. In general, we would not be able to figure it out. We have to make cases. But here we are able, we can be safe to make that assumption. Okay. So the heat lost by metal is how much? The change in the temperature, which is 1400 degrees, into the mass, into the specific heat capacity, which is given as 0.1. So this is the heat lost by the metal, and it has to be equal to the. So let us say that x grams. So let us say
Will not lose the heat of will not uh, lose the temperature of 100 degrees Celsius. Na? 100 water will gain the temperature of 100 degrees Celsius, so there will be change of 60 degrees Celsius in water. But
yes,
we
correct.
don't have the value of change in temperature of metal blocks, so we cannot minus 100 now.
No, but this is just the change. This line is only referring to the metal part. Here we are not looking at the water at all. So metal is just going to cool from 1500 to 100 degrees. That in that process, it is going to give off this much heat. Is that correct? Okay. So now we are coming to the second part, that how much heat is absorbed by the water and the steam, and we are going to equate that. So for that, what I am saying is that let x grams of steam be produced. Okay. So that x is what we have to find out, right? Let us say that x grams of steam has to be produced, right? So the total heat gained by the water plus steam. So what are the process? What is the total heat it is going to gain? It is going to be the heat required to go from 40 degree to 100 degrees. That part doesn't change. That all the water is going to change that, right? So that is simply going to be 60 degrees. That is the change in the temperature into the mass of the water into specific heat capacity, which is 1 calorie per gram degree Celsius. So this is the first part where only the water is raising the temperature to 100. Plus, in addition, whatever part of the water became steam, which we don't know, so we are calling it X, right? So X grams of the water which became steam, how much heat is that going to absorb? For that, we have to look at the latent heat of vaporization given, which is 540 calories per gram. So if 1 gram requires 540 calories to become steam, X grams will require 540 times X. So this is the total heat lost by the metal, and this is the total heat gained by the water plus steam. And so they have to be equal. And again, the only variable here is x, right? So if we solve for x, we should get the answer.
Sir, how that 60 came there? 90 into 60.
This term, this is the term, this is how much heat the water has to absorb, because initially all the water was at 40 degrees. So
Hmm.
before even it starts to become steam, all the water has to become 100 degrees, no?
Yes.
So it has to rise by 60 degrees.
Okay.
So
Yes,
I mean,
sir.
so yeah, correct. So I mean,
Hmm.
this intermediate picture which I was drawing here, this.
Okay.
So this is a two-step. Like first the water becomes 100 degrees and then it becomes steam, some of it. Okay, so if we just equate this, so 1400 into 60 is equal to 60 into 950 plus 540x. I think 60 will cancel from everywhere, and we are going to be left with 9x plus 950 is equal to 1400. So therefore 9x is equal to that 450. So x is 50. So in other words, out of the 950 grams of water, only 50 grams will become steam. The remaining 900 will remain water only because and you realize why this is happening. Understand one very nice the way the calculations are set up. That why here all the water is not becoming steam because this latent heat is so high. Just converting from water to steam is each gram is going to consume 540 calories. That is such a huge amount of heat. So that no matter how hot that block is, it is not going to be enough to convert all the water into steam. To convert all the water into steam, the block has to be even hotter than this, maybe not 1500 calories degrees, maybe 5000 degrees or something, some crazy number like that. So realistically, all the water becoming steam is an impossible event. But on the contrary, going back to the previous question, here all the ice became water. Why? Because the latent heat of fusion of ice is much smaller. It is only 80. So converting ice into water does not take that much heat. But converting water into steam takes much more heat. So look at that ratio of the two quantities involved. Okay. But the answer is 50.
Sir,
Okay. I
please
hope.
show the solution.
Yes. Okay. Yes, Adhiraj.
Sir, won't the temperature of the steam rise from 100 to like 101, 102?
It cannot rise because even if it rises, right? See, the whole system has to come to an equilibrium to one temperature. So
Yeah.
if the steam becomes 102 degrees, but everything else is at 100 degrees, again the steam will lose its heat to that, right?
Yes, sir.
Only when all the water has become steam, after that the all the steam will start to increase in temperature. Otherwise, it will remain at 100. Okay, so I think we have finished the questions that we were planned to do today, and we have some 12 minutes left. So we can discuss the remaining two questions from last time, question 19 and question 20. But I hope that, I mean, because we had discussed similar question last time, everybody is already comfortable with these two questions. I hope you already tried them, solved them. Can you raise your hand if you already solved question 19, for example? Okay, few of you have solved it. So I'm not going to calculate question 19. We are just going to read the question and understand the strategy because the calculation part is very straightforward. Yeah, I see many of you have done it, which is good. Because what is given, see, reading the question just as we had thought last time that what is the information given, what is it conveying to me, that there is a mass and a speed given. Which concept has mass and speed? Momentum, right? And so the whole question is revolving around conservation of momentum. That is what it is testing. That mass A has some momentum, mass B has some momentum, and they are both going in one direction. And mass C has a momentum, it is coming from an opposite direction. So in terms of magnitude or in terms of sign, A plus B plus C, all of the combined momentum, they collide and the total velocity becomes zero, which means all the momentum cancel each other. So the initial total of the momentum of the system is equal to the final momentum of the system, which is zero. So just equating that basically 10 times 1 plus 20 times 4 will be the moment of A plus B combined, and 30 times U is the momentum of C. So they have to be equal, right? So 10 plus 80, 90 is equal to 30 U. So U has to be 3. So is U the answer of U is 3? Yes, it is 3. Okay, I'm just worked through this example without writing anything, but I hope everybody has understood. Or at this point, I expect that everybody should get this question. Okay. Otherwise, go back and revise your basic concepts of law of conservation of momentum. Okay, and what about question 20? Anybody who's already solved question 20? Okay, we'll solve question 20, but again, I hope that it is not a really new thing. We are just, there are some objects which are moving with some acceleration, and some information is given that this object moves for this much time with this much speed. So we can figure out that how much time it takes and so on and so forth. It is just calculation. So, hopefully you should start to get this confidence that, हाँ, ये तो आता है. This is like, you should not be scared of the question anymore. Okay, what is given? How will I find something? So like the step one, like figure out the physics is not the difficult part. Just getting the mathematics correct without any calculation mistake. Focus on that. Getting all the signs correct. That is all that is going to matter here, right? So the diagram is going to look something like this. So team A and team B, and the player A1 and B1 start at the starting line. And so let us first look at only A1. Or let us completely work out what is A1 going to do, what is A2 going to do. So A1 starts at t equal to 0, and A1 starts to accelerate at 1.2 meter per second square. So in my diagram, I can show that A1 is going to accelerate 1.2 meter per second square. And how long does he accelerate? It is given up to for 5 seconds. Okay, so for 5 seconds, so at t is equal to 0, he is here, and up to t is equal to 5, he is accelerating. After he finishes acceleration, he is going to run at a constant speed. So at to this point onwards, some constant speed, which I'm going to call v, until he reaches 75 meters mark. So this distance is 75 meters. Okay. And as soon as he reaches this, A2,
The screen is not visible.
oh, sorry, I was. So A1 is going to travel first part of, so this is again like that rocket, right? The phase one of the rocket is like this 1.2 meter per second square acceleration. Then for some time it is going to be constant velocity. After 75 meters from here, A2 is going to start running. So what is given about A2? A2 has a different acceleration. A2 starts with 1 meter per second square, right? So A2 has an acceleration of 1 meter per second square. So A2 is going to run for how long? Again 5 seconds he is going to accelerate. So for 5 seconds they are going to accelerate, and after that he is going to travel at constant velocity. So this is the entire trajectory of team A. That this is all the things that team A is going to do. And similarly, can we draw a diagram for team B also? So what is team B going to do? What is B1 going to do? So B1 starts with 1 meter per second square for 6 seconds. So the values are different, but the principle is kind of same. So 1 meter for 6 seconds. So we don't know where he will reach here. And then at constant velocity, it is going to reach up to 72 meters. So B1 is going to travel for 72 meters. Then at this point, B2 is going to start traveling. So how much is B2 going to travel? B2 is going to accelerate at 5 by 3 meter per second square. So I already get the feeling that this is a very calculation heavy question. Like the main thing is getting the calculation right. So B2 is going to travel for 5 seconds. And after that, B2 is going to travel at constant velocity. And what is asked is at what time do they cross each other? So presumably at some point, these two are going to meet again. And so we have to find out at what time they are going to meet. Okay, so the diagram looks complicated, but really there are lots of small things that we need to figure out. If you put everything together, we are going to get the answer. So always what we are going to do, for a question like this, it is very important to think in terms of uh, pairs of numbers. So always we are going to write pairs of numbers, like what is the location and what is the time. So this location and time is going to be our way of representing all the events. So you can think of each occurrence as an event, like A1 starts to accelerate, A1 stops accelerating. He gives the pattern to A2, A2 starts to accelerate, A2 stops accelerating, and at some point they meet. So all of these events, I can specify that what is the distance, and always I'm going to measure the distance from this line, like this is my reference line, that this is the line 0, right? Sorry. So all the distances I'm going to measure from this line, and if I just work it out, I should get the answer. So let us do it. Okay, so first let us look at A1. So A1 starts at location 0, time 0, right? So A1 starts at location, so I'm writing S for displacement, but that is the same as location. So first part where he accelerates at 1.2 meter per second. So acceleration is 1.2 meters and time is given as 5 seconds, right? So therefore, can I find the distance? How much distance is he going to travel in the first 5 seconds? So that is going to be half into 1.2 into 5 square, right? Right? So, so therefore I can start to put the values on this diagram that at this point A1 was at 0, 0. So understand what is the 0, 0? This is the distance and time. So 0, 0. At this point, he's traveling for 5 seconds. So the second part is 5. And what is the first part? This is 15 meters. So he has traveled for 15 meters in 5 seconds. And how much is the velocity at this point? V is equal to ut. Oh, sorry, u plus at. Sorry. So actually, I find this to be a very boring question. But anyway, let us finish it quickly. So the 1.2 meters per second square for 5 seconds. So he is going to pick up velocity of 6 meter per second. So at this point, we also know the velocity, right? This velocity is 6 meter per second, right? And so now from this point up to 75 meter mark. So 15 meter to 70 meter. So there's a distance of 60 meters to be covered, right? So 60 meters to be covered in 6, right? So 60 meter to be covered at 6 meter per second. So that will be done in 10 seconds, right? So he is going to be running for 10 seconds. So again, can I write the coordinate at this point? That the distance is 75. Distance from the starting line is 75. And how much is the time? 5 seconds previous time plus the 10 extra seconds. So total 15 seconds he has been running so far. So this is where A2 is now. And from here, now A2 is going to start their journey. So again, we have to plot for A2 that first 1 meter per second square for 5 seconds. So how much is this distance going to be? So this question is just repeatedly solving the same equation again and again, kinematics equation. So for A2, this part is going to be again ut plus half at square. U is 0 because A2 is starting at 0 velocity. So it is going to be half into acceleration into 5 square, right? So that is going to be 25 upon 2 or 12.5. So
So,
A2 is going to, yes.
so you could even do like 60 meters is 10 seconds, therefore 75 meters is x, and then 10 into 75 upon 60 will be equal to the.
Sorry, can you repeat that? I did not get it.
You can even do like 60 meters is like 10 seconds, 75 meters will be x, so then x equals to 10 into 75 upon 60.
Yeah, but what is x in your equation?
12.5 only.
1.5.
12.5.
Okay, got it. Yeah, okay. Yeah, that we can also do that. Okay, so this distance is 12.5 meters. So again, can I write the coordinate over this point at how much distance from the starting line? So original 75 meter plus this 12.5, right? So that is 87.5. 87.5 meters. And how much time has been taken so far? So up to 8 to the first part was 15 seconds plus 5, so 20 seconds. Okay. So I'm going to pause here that we the last part we will calculate at the end, but so far this is what we have understood that, and yeah, we have to find the velocity also, right? Because that is the velocity by which he is going to do the final part. So we have to find the velocity. So velocity is going to be u plus 80. So again, that is u is 0. So this is simply 1 into 5, which is 5 meter per second. Okay, so the diagram has already become very messy, so that is why I'm not drawing the last part here. But so far, I hope everybody has understood. Just 3 parts we have calculated again by repeatedly applying the same equation. So we have to do the same thing for B now. So let me draw the diagram of B separately over here. So B is starting here. First 6 seconds, they go at 1 meter per second square acceleration. Then up to the 72 meter mark, they travel at constant velocity. This is B1. Then B2 start from here. What does B2 do? B2 accelerates for 5 seconds at 5 upon 3 meter per second square. And then again after that at constant velocity. So again, we have to find the coordinates of all these 3 points. Okay, so let us quickly do that. So the first coordinate is going to be S will be ut plus half at square. So half into 1 into 6 square. So this will be 18. So 18 comma 6, right? So again, I'll speed up a little bit because we're already out of time. So 18 comma 6 is this first point, and the velocity that the person has picked up is a into t, which is 6 meters per second. So at 6 meter per second, they have to cover the distance from 18 to 72, right? So 72 minus 18, that is the distance to be covered at 6 meter per second square. So the time taken will be equal to 72 minus 18 by 6, right? So time taken is, which is 12 minus 3, which is 9. Right? So in other words, they are going to travel for 9 seconds from this point to this point. So we know the coordinate of this point also. So that is 6 plus 9, 15 seconds time, and the distance is 72, that is given. And so at this point, V2 starts to travel. V2 again, we know the acceleration, we know the time. So the first lap of V2 is going to take how much distance? So S is going to be ut plus half at square. So half into 5 by 3 into 5 square. Is that? Yes, okay. So 125 by 6. It's not a very nice number, but I hope it will work out in the end. So the distance traveled by B2 is 125 by 6 meters. And the how much is the velocity picked up? So velocity is simply going to be 5 by 3 into 5 seconds. So that is 15 upon 3 meters per second. Okay. So at
25 by
25, sorry, correct. So velocity is 25 by 3 meters per second square, per second. And what is the coordinate? The distance traveled is original 72 plus this 125 by 6, and the time taken is 15 plus 5, 20. So now we can show the position of A2 and B2 in a separate diagram at the moment that they start traveling at constant velocity. So A2 is somewhere, B2 is somewhere. So again, going back to what was A2's coordinate, the last time we saw, the A2's coordinate was 87.5, 20 and traveling at 5 meters per second. And traveling at 5 meters per second. And V2's coordinate we just found out right now, 72 plus at 20 seconds. So one good thing is that they are both at 20 seconds. So the time is both 20 seconds. So basically when they both start to run at constant velocity, the initial clock is the same, which is one good thing. Otherwise that would add one more complexity to our calculation. And B is traveling at 6 meters per second. So now the only thing to be figured out is that at some point they are going to go and meet, right? So where if we call that unknown point of time as t, right? Let t be the time when they finally meet, and hopefully this question will be over. So then the last thing to be figured out is that so distance traveled by A, right? So total distance traveled by A2 will be 87.5 plus t minus 20, because already up to 20 seconds he has traveled. So the last t minus 20 seconds he is going to travel at 5 meters per second. And this should be equal to the distance traveled by B2 because they are meeting there, right? So distance traveled by B2 will be original distance which B2 has already covered, or other team B has already covered, plus the last t minus 20 times 6. So you have to equate these two to get the value of t. right? So let us do that. So 87.5 plus 5t minus 100 is equal to 72 plus. I hope that's upon 6 vanishes. If it does not, then we are going to get a fractional answer. Yeah, let's, I don't know. I have made some calculation mistake because I don't see how that 6 is going to cancel. Oh, sorry. So in this equation, t is the only unknown variable. So if I put it to one side, I'm getting 120 plus 87 pi minus 100 minus 72 minus 125 by 6 is equal to t. And yeah, I don't see how this 6 is going to get cancelled. So I think I made some calculation mistake somewhere along the line. Okay. But as I said, that this question is really just testing your patience. It is not testing that much physics, to be honest. And it is not like there is some slight trick like symmetry or anything which we can use to simplify the calculation. We have to work it out in detail like this anyway. So yeah, there is no other alternative but to solve it. Maybe try to solve it more systematically. Maybe there is some small mistake I did somewhere, or I don't know if there is a mistake in the question itself, which we have to see. I will post on the WhatsApp group. Okay, once I solve it properly, I'll tally the calculation and the final answer. I will post it on the WhatsApp group for us. But I think, yeah, so we have covered all the questions. And I also have some additional questions for you to practice, which I will also post on the WhatsApp group for you. But I hope that these two sessions of physics were useful for you to start thinking in the right way. That gain the confidence that you know your physics well, you know how to do calculations well, and if you just put those both things together, then I don't see any reason why you shouldn't score 100 out of 100 or whatever is the total marks in the physics part. Okay, so that can be your objective, very realistically speaking. So yeah, that's all which I wanted to share with you. Any last question before we leave?
No, sir.
Okay,
Congratulations for the patent.
yeah, would you like to listen about the patent, and Prashant, would we understand what you did? I don't know if you can brief it quickly.
Okay, I cannot talk about the patent directly, but let me
Yeah.
explain very briefly what is the technology that we are dealing with. And you know, we are using it today, right now. We are using Zoom, and the reason why we're able to use Zoom is because of some of the inventions that are created in this direction. Because if you think about it, you're looking at a monitor, right? If you take a magnifying glass and look at the monitor very closely, do you know what you see? We see pixels, right? And what are pixels? They are just small LED lights which have colors like red, green, blue colors are there in the pixels. And so what is happening, like my camera is capturing my image, it is taking all the values of the pixel, it is sending that information over the internet to your laptop, and your laptop is showing that image. And all of this is happening right now, all the time. Every second, 30 frames are being processed that way. So that alone is amazing that it is able to do this processing. But if you calculate that how many pixels are there on the screen, and how much network bandwidth you will require to send all the information, you will realize that that is a very large number, that you will require maybe 100 Gbps, 500 Gbps connection to use Zoom. But we don't have that good connection today, right? Maybe 100 Mbps, maybe somebody has gigabit internet, but nobody has that good internet. So then the question is, how is Zoom able to run? How are you able to watch YouTube and everything if your internet is not that strong? So there is a lot of cleverness that happens behind the scene to reduce the amount of information you need to send. Because if you observe, like you are seeing my image, right? But my background is completely white. So why will Zoom send that white image again and again that the background is white now? Again, after 1 second, the background is still white. After 1 second, again it will say the background is white. So it will keep repeating the same information again and again, which is not required. If the background is white now, it is going to remain white for a long time, right? So that is how cleverly you can reduce the amount of information. Only I am speaking, only I am moving. So only my pixels will be sent by Zoom. The entire image will not be sent. So these kind of clever tricks are used in what we call compression of data. So the data is compressed in a very small packet and then it is sent over the internet. And same principle is applied when you have used zip file, you zip a file and you unzip a file. The size of the file suddenly reduces. How is that possible? Because if you think about it, a file has the same letters occurring again and again. Like if you have an English storybook, so it will have the same 26 characters repeating again and again. So it can use very clever tricks to reduce the amount of information required. So that is a very brief way in which I can explain the topic of my patent, but I think we don't have enough time to go into details. But I hope you are interested by all of these things because it is at some point you will be designing even more complex systems than what we have today. So yeah, I hope, wish you all the best.
Okay, thank you, Prashant. Coming to our Thursday sessions, I had sent some extra questions from the past papers, which I would like to discuss because as we spent some time in discussing the strategies and basic things in our first lecture, second lecture we can straight start with the second paper. Maybe I would like to discuss the last question of the first paper, for which I think I could not give enough justice. So we will have extra time in our hand, and I would like to discuss the special questions that I've sent across to you because I feel those questions have uh, some some hints or some glitches, mm, which if you note you will be better off in analyzing the questions in the paper. So those typically 4 or 5 questions which I've sent, please try to solve them. We will discuss them, and then if we have some time in our hand, we can look at further a few more questions. Okay, so Thursday we will straight start with question 10 of January 2023, and then we'll jump to April 2023. Right? Okay, that's from my side.
Okay, thank you
Yeah.
then.
Yeah.
See you on
Thank you,
Thursday
sir.
for the chemistry session.
Yeah. Bye.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir. Congratulations.
Thank you.
Thank you, sir. Bye, sir.
Bye.
Congratulations, sir. Bye.
Thank you. Bye.